That's like what's always been very confusing to me about T-Rex, honestly. Like, they're an apex predator, but you look at your arms and you're like, man, what are you doing with those?
Come on, man. Those are just silly.
Woo!
Hi, welcome back.
Yeah, welcome back to the Random Theory Podcast. I'm Grace.
I'm Josh.
And together we explore random science things with our science pals, which is you, our listener.
You listener are a science pal. Yeah, exciting. A full year, another year.
Talked about some crazy things.
Yeah, we did talk, podcast-wise, we definitely talked about some real crazy things.
And there's still more to uncover.
And there's somehow still more, probably some more pee podcasts coming at you.
Probably, somehow, some way.
Somehow there's another thing to talk about involving urine. But yeah, it was an exciting year.
It was. And what we like to do at the end of the year is wrap up 10 science topics that
notable events.
Yeah, really impressed us this year.
Yeah. Last year we had, sadly, there was the Doug news.
Doug the potato was not a potato. He was a gourd.
It turned out to be a gourd. We talked about him.
Really devastating stuff.
It was a big blow, for sure. But yeah, how you doing?
I'm good. We're recording this before the holiday season, so that
this will come out after Christmas.
The day after Christmas. So Merry Christmas.
Yeah. Merry Christmas yesterday.
Yes. But we're, Josh and I are both traveling, and we wanted to make sure our editors that do this podcast could do their thing too. So,
Yeah, it is exciting. I know our editor that edits this podcast is going to see his brother.
Yes.
Who edits our normal YouTube videos.
Which is kind of cool.
And they said they haven't spent time together since 2 years. It's been 2 years since they spent time together.
I really hope they send us a picture.
But yeah, we're recording this early. We recorded 2 other ones that you've
probably heard already.
You've heard one. The other one's coming out next week.
Yep.
Because we're just trying to round out the end of the year so we can all get on with all of our
I can't believe we're here.
Stuff. I know, right?
It's kind of crazy.
This year is definitely felt one that taken forever, but also it blew by. It didn't go fast enough.
I don't know. This year to me, I just feel like, because we had a lot of changes if you watch our YouTube channel, TKOR, we had a lot of changes that happened this past year. Yeah. And I feel like you and I have just been running, trying to get our feet underneath us. And I feel like finally we're stabilizing. We're figuring it out.
A year later.
Figuring it out. Yeah, it's just like, a year later we have done the thing. And there have been so many learning curves, but it's all good.
It is all good. Definitely all good.
It was a year of growth, that is for sure.
Big growth.
I was not expecting such a year of growth, but it really was.
Yeah. So before we get into some cool facts, should we read some reviews, some ratings?
The rating and reviews from the last ratings and reviews of 2022.
I've got an email.
Okay.
From our email, randomtheorypod@gmail.com. And this is coming from a mom.
Oh, wow.
Uh-huh.
That's sick.
And they're writing they included a review from their son, who I guess has written us on Apple Podcasts.
Oh, cool.
And I recognized the name. The email comes from Tara, which is the mom's name. And her son's name is Alex.
Alex and Tara.
So the email starts out and just says, "From my son, Alex. Hi guys, my name is GCU.
Oh yeah.
But my real name is Alex. In my first rating and review, I left a joke saying, knock knock.
Who's there?
Banana.
Banana who?
Knock knock.
Who's there?
Banana.
Banana who?
Knock knock.
Who's there?
Banana. Okay, it goes on.
Yeah.
I'm not kidding. He put a paragraph in here. It ends with knock knock.
Who's there?
Orange.
Orange who?
Aren't you glad I didn't say banana?
I remember that one very vividly.
After you called it a classic little kid knock knock joke, which is funny because I am a little kid. I'm only 9 years old. You guys rock one. I don't even know what number that is out of 5 stars. It's like
That's amazing.
I don't even quadrillion. Who knows?
I'm so glad we know GCUVUVU's name is Alex now.
Alex. So then there's a PS from the mom.
Okay.
PS from Alex's mom. Thank you for being a family friendly podcast and YouTube channel. Our entire family, aged 4 to 42 has enjoyed watching your channel. I especially love when you show when things don't go as expected. So many times, my children think things will magically work like they did on a highly edited YouTube video, and then get frustrated by the process of experimentation. Kudos for talking about those failed attempts that TKOR overcomes in the course of making your videos. Alex has also enjoyed your weekend project book and, with some adult help, created the grill made out of a can and the marshmallow shooter.
Oh!
Tara. Thank you so much, Tara and Alex.
Yes.
For that review. I'm glad you enjoy, what would you call it? The fails?
Yeah.
I mean, that's...
The attempts. That's science.
That's science, right? Like, yeah, we have those all the time.
There are days that we spend filming that like doesn't even make it into edit because literally we're just sitting there trying to figure it out.
Yeah, but I feel like we've tried to include them more now.
I think we have as well. For a long time, they were something that wasn't included in the channel.
Mm-hmm. Yeah.
Because that's just how Grant wanted it. And then with Nate, it was the same way because he was still under Grant's wing. Yeah. With me, I'm all about the failure. Because for me, I'm a scientist. Yeah. Like by trade, I am a scientist. So I think it's so important to show that you have to fail, and that makes the success that much sweeter.
Yeah. Well, and you have to go through the process to achieve something.
It's the only way to learn is to fail.
Well, and like, you know, we say this all the time here on the podcast, but in everything, on the YouTube channel, like we are not experts.
No.
So we don't want to make a video and have it be this highly polished thing that comes across like we're the experts.
Right.
I mean, you know, on the podcast, we try to do our research and we want to convey factual information.
Yeah.
We don't want to fool somebody out there and think like, oh, these guys know everything and it's all good to go.
Like we've said many times, we are a very shallow pool.
Yeah.
Of information that's very long.
It's a very long, shallow pool of information.
But thank you, Tara and Alex. That was so sweet.
Yeah, thank you so much.
Mine comes from, it's off of Apple Podcasts.
Okay.
And if you don't want to send an email, you can leave us a rating and review there. And if you're listening to this podcast, please, you don't have to leave a review every single time. If you love the podcast, that would be fantastic. But leaving a rating every single time you listen to the podcast helps us out so much.
Yeah.
Like our big goal for 2023 is to really have the podcast explode. And the only way we can do that is with your guys' help.
Yes.
So sending this to your friends that you think they'll enjoy, leaving us a rating, and then leaving us a review about a podcast topic or a joke that you really like. So this one comes from Foxy3021, and they titled it Awesome.
Okay.
5 stars.
5 stars.
Thanks, Foxy. They said, I love this podcast and it's very awesome. You should all listen to it. I even subscribe to it.
Nice.
Sweet. Thanks, Foxy.
Thank you so much, Foxy. Especially for that subscription. That's huge.
That's so big.
If you enjoy the podcast, make sure you're subscribed to it so you get it automatically when it drops Monday at midnight. Mm-hmm. On podcast platforms.
Also, something new coming to you all this year.
Yeah.
It's going to be called Snappy Science.
Snappy Science. Short, like middle of the week?
Yeah, middle of the week pods.
One episode.
Yep.
Middle of the week that's going to be just like 5 minutes probably?
Yeah, whatever. Like, it's basically going to kind of be how... like what we're doing here, where we find a topic or something scientific happens this week or something big in the world. Yeah. And we just kind of talk about it. It's a quick, snappy little segment. Yeah. It'll be either given to you by me or Josh. And it's basically just to keep you informed about cool things happening in the world. Yeah.
Yeah. It's just an additional fact.
Yes.
One more thing you can add to your annoying party quiver.
Yes. Quiver. What a good word.
I know, right? I just busted that out. But yeah, so that is coming first week of January, right?
Yep.
Yeah.
We'll see how it goes.
We haven't actually recorded one yet, but
because they have to be recorded in real time. That's
true.
That's the hard part. Is it'll be
it's a quick turnaround.
Yeah. It is what it is. But it's audio only. So if you watch us on YouTube,
sorry.
Yeah, you're gonna have to scoot your booty over.
You're gonna have to slide over to a podcast platform of your choice to hear
Snappy Science.
Snappy Science. Should we get into the wrap up?
I feel like we should. I feel like it's time.
It's time.
Okay, so mine is human tendons growing on robot skeletons.
That sounds scary.
It's very scary, but it's also, I think, really awesome and mind-boggling.
Okay.
So if someone has ever torn their ACL or ripped something in their shoulder, their knee, a joint, going in and repairing it is really tough. It's tough on the body. It's a lot of physical therapy. So nowadays, most transplanted organs or tissues come from a living or deceased donor, sometimes even from other parts of a patient's body. However, in the future, all transplant tissues may be grown from scratch. Ghost stem cells, number one. That's like huge here.
Yeah.
Stem cell science is very new and progressive.
We talked about, I don't remember what episode that was, but there was an episode we were
I think it was last year.
Raving about stem cells.
Yeah. I think it was a wrap up last year. We talked about
was it really?
Them growing ears.
We did talk. I do remember
ears,
the ears. Yeah.
So scientists have been trying to grow tendons suitable for transplantation into human patients in laboratories for years. Although they've grown tissues successfully, aka ears, different skin, cartilage, like they've done a lot of that.
Yeah.
They have not had the same robustness as human cells. That is because naturally growing tissue undergoes constant stress. So when a person moves around, the tissues are compressed, stretched, twisted, and this improves their flexibility and function.
Right. We got some real robust cells going on.
Yeah. So like think about like the tendons in your body. They need to be like moved around, which I think is really interesting. So to create a more successful tissue, science has developed a platform that mimics the motion of the body. So this came from the journal Communications Engineering journal people.
Them.
Yeah.
Yeah.
So an artificial tendon.
Supraspinatus.
Tendon.
Yep.
Was formed by placing a bioreactor atop an artificial shoulder skeleton, which replicated the placement of the supraspinatus tendon. The
tendon that is in your shoulder, I assume.
Yes.
Yeah.
And after 14 days of it growing, the shoulder moved around to simulate the natural movement of a shoulder.
Okay.
Which is amazing.
So, yeah, it was literally just like they grew it on something that then artificially moved.
Yeah, and then surgeons were able to go in and just like take it and then put it in.
And
it's already ready to be moved around and it's been stretched and it's
like when people make taffy. And
you
have to work it.
Yeah,
you know?
Exactly. Yeah.
Yeah, that's cool.
So an analysis of the transcriptome of the cell after 14 days in the reactor revealed increased flexibility and function. They say it'll take a while for them to be able to grow completely transplantable tendons, but building them on these artificial bodies is a great step in the correct direction.
Right.
Which is fascinating.
This kind of stuff makes me slightly hopeful for the future.
Yes.
Blowing a shoulder tendon and then being able to just 3D print one out of stem cells,
right,
and put it on a artificial muscle that's moving around to work it into place. Like, that's incredible.
I think it's so helpful, especially for people like say they don't have high mobility. This is something that is really good for them because they already have a tendon that's like ready to go. Yeah,
that's true. Should we move on to my first one here?
I'm ready.
So mine, I was telling Grace because we did 5 each. 3 out of my 5 are space related.
Big science guy.
Big space science guy over here, as you listeners might know. And it was a big year there was a lot of space things happening this year.
It was a big space year. It was a big space year.
I couldn't not mention it. First up is the James Webb,
of course,
telescope, which I have a note here. Technically, it started in 2021.
Sure.
But the big moments happened in 2022. So the James Webb Space Telescope, also called Webb or JWST, is a large space-based observatory optimized for infrared wavelengths, which will complement and extend the discovery of the Hubble Space Telescope. It will have longer wavelength coverage and greatly improve sensitivity. The longer wavelengths enable Webb to look further back in time to find the first galaxies that formed in the early universe and appear inside dust clouds where stars and planetary systems are forming today.
That's so mind-boggling to me.
Yeah.
Like, I mean, honestly,
it's revolutionary that we have it up in space right now doing its thing.
The images that have come back from it are just they hurt my head to look at.
Yeah. To think that that's like out there.
Yes.
Like if the one for me, what did they call it's like the pillars of creation or whatever.
Yeah.
Just looking at that, I'm like, that is somewhere out there.
Yes.
Existing.
Light years away.
While I'm currently sitting here existing.
Writing a podcast.
Crazy.
Reading a podcast.
Right, reading a podcast about it. So first up, because I was curious, who the heck is James Webb?
Yeah, who is this?
Right?
Who is this guy?
Who is this guy? Why is it called the James Webb?
Why him?
The telescope is named after James E. Webb, who was actually NASA's second administrator, best known for leading the Apollo missions.
Interesting.
So
he seems like he should have a telescope.
Worthy of a telescope naming.
Yeah,
I feel. The launch of it actually took place on Christmas Day, December 25th, 2021. It was launched on the Ariane 5 rocket from the European Space Agency spaceport located near Kourou, French Guiana.
Sure.
Certain launch constraints meant that there were about 210 days a year spread across the year when Webb had launch windows.
Okay.
The duration of those windows varied, and some only lasted about 90 minutes.
That's crazy.
So there was only 210 days that they could even launch it. And on those days, sometimes they only had 90 minutes to make it happen.
That feels very stressful.
So yeah, Christmas Day, like they were like, yeah, you're working Christmas Day.
They were like, this is the best Christmas present ever.
So then the other big thing, deployment and the first images, the telescope took 2 weeks after launch to fully deploy in space. The deployment process was incredibly complex and unprecedented and had to be performed really slowly to minimize the risk of something going on or going wrong. And then over the next 6 months, the telescope was able to calibrate its instruments, and then NASA finally released the first deep field image on July 11th, 2022.
The patience of these people.
I know, right? Could you, well, and like, literally, it's just unfolding, and it took 2 weeks.
For it to completely
And just
unfold.
like, some people were just watching a computer, like making sure something didn't happen. Which I think, I didn't write it on here, but didn't it got hit by something.
Yeah, one of its sensors got hit by like microscopic meteor.
But, and it was, I remember it was like big news and people were like memeing it, like, oh, you know, this.
I think it was funny because it had literally like just released the image and then like maybe a week later was damaged. And like everyone was like really like.
Yeah. But the thing is NASA was like, well, yeah, we knew that was going to happen. There's 12 other redundancy sensors on it. Don't worry. Like they planned for it to get hit because it's space. Yeah.
That's so cool.
Big thing this year.
That was huge.
That will continue on for many, many years.
Yeah. Speaking of something else that's kind of world changing.
Okay.
In its own
I feel like most of these are.
Yeah.
Yeah.
Mine is coral reef printers.
I mean, that sounds rad.
Coral reefs are a critical part of our ocean's ecosystem, and they're actually suffering from the effects of human activities, including global climate change, which is a total different conversation for another day that we're not going to get into. No. We actually talked about coral reefs and how they are important in the fish pee episode.
Fish pee?
Yeah.
They grow from fish pee.
They do.
Yeah.
Reefs account for only 1% of the Earth's total surface, but they sustain the highest level of marine diversity in the world, which is very important. If our reef system fails, it will have staggering impacts not only on our ocean's ecosystem, but on people all over the world who depend on them. I mean, we already saw like millions of crabs just die
vanished.
And disappear.
Yeah.
Just
gone. Went away.
It was national news.
Yeah, for like a day.
A day.
Yeah.
Crabs disappear.
Yeah.
And I feel like everyone just turned the other cheek. And that bothers me because a whole species, a stupid amount of crabs just disappeared. 11 billion crabs.
Gone.
Disappeared. This will have impacts beyond, like the whole food chain has shifted and changed now.
Yeah.
The whole food supply chain, not just for humans, but for that ecosystem has changed.
Yeah. Well, and that's the thing. Like if you're a kid or whoever just listening to this podcast and you're like, well, I don't eat crab.
It doesn't matter.
It doesn't matter because even
a fish eats crabs.
A fish eat, and even if you don't eat fish, like also this is potentially just indicative of other things to come.
Yes.
So even if you don't eat Alaskan snow crab, yeah, you might eat the fish that eats that or something else in the ecosystem that depends on the waste of that or whatever, because everything is connected. and now 11 billion of these things is just gone.
So if our reef system fails, it's going to have staggering impacts not only on our ocean's ecosystem, but on people all over the world that depend on them. So consequently, conservationists are working hard to come up with new and improved ways to sustain and restore remaining reef systems. So a new paper published in the journal Science of Total Environment reveals how conservationists are using 3D printers to construct customized artificial reefs.
Dude, 3D printers, man, they're the
amazing.
Future.
They are the future. And what's even cooler, in this paper, it basically explains how the process begins with scanning the existing reef to identify its core characteristics, which is important because every reef has its own personality that's important to the fish that are eating off of it.
Yeah.
And they replicate them as close as possible. Then using a custom printer built in partnership with the Technician Institute of Technology, the reef is laid out. Okay. But instead of using plastic filament, this is what's so big. Yeah. Because there are already microplastics in fish that we are eating, and they're finding them in humans. We certainly do not want to
introduce.
No, we don't need more plastic.
Yeah.
So they're using terracotta clay because it is more porous and favored by the coralline algae, which helps create coral.
Gotta have the algae.
Yeah.
Yeah.
So moreover, the printed reefs can be made modular and stacked such that vast portions of coral reefs could be rebuilt while maintaining the structural variety seen in nature.
How cool is that? I just thinking about old technology, new technology. Like, how long has terracotta clay been around?
As long as dirt has been around.
Forever, yeah. Like, literally. And now they're using brand new technology of a 3D printer to print out
these reefs.
That's amazing. So next up, number 4 on the list. This just happened.
Literally just happened.
Nuclear fusion, which I feel like I've been hearing about this for years, and I think it is because
I feel like every year they get a little
they do a little something else.
Yeah.
And that's kind of what this is, and I feel like that's with like all of these things on this list. It's like it's a step.
It's one step.
It's one step closer to something.
Yeah.
For more than 60 years, scientists have pursued one of the toughest physics challenges ever conceived: harnessing nuclear fusion, the literal power within stars, to generate abundant clean energy here on Earth. So this is like end goal power.
Yeah.
Like if they do this, we're good.
We're good. No more coal, no more oil.
No more any, like we wouldn't need anything. Like solar wouldn't matter, wind. I mean, we'd probably still use it a little bit in places, but like this would change everything.
This still blows my mind.
So on December 5th, a massive milestone in this goal was achieved. An array of lasers at the National Ignitions Facility fired 2.05 megajoules of energy at a tiny cylinder holding a pellet of frozen deuterium and tritium, which are heavier forms of hydrogen. Mm-hmm. The pellet compressed and generated temperatures and pressures intense enough to cause the hydrogen inside it to fuse. In a tiny blaze lasting less than a billionth of a second, the fusing atomic nuclei released 3.15 megajoules of energy, which was about 50% more than had been put in to heat the pellet. That was huge. Up to this point, it's taken more energy put in by lasers than it created out. Like they just weren't able to achieve that. So the dream of nuclear fusion power plant is still a very long way off, but the NIF results show that it is possible, at least for a fraction of a second, because this literally only lasted a billionth of a second.
3.5 megajoules equals 972 watt hours.
Okay, that's a lot.
So generally light bulbs use between 2 and 100 watts of electricity.
Okay.
Depending on their size and type. LED bulbs use 2 to 18. So a typical house, essentially items will average 5,000 to 7,500 watts of power to run. It's not like a lot
in the grand scheme.
But it's a lot. Yeah.
Well, yeah, I mean it's a lot.
But also you can't just throw a laser beam at like a giant chunk of this stuff and be like, do your, like can't be like, I mean, like that's so sketchy.
And I read so the place that did this was not what they were actually like. They weren't trying to do this.
Oh, really? So, it was an accident.
Well, I mean, they knew what was going to happen, but the facility, what's it called? The National Ignitions Facility?
Yeah.
actually, what they do is they safely ignite nuclear bombs.
Gotcha.
To basically, I think it was like test their safety and how well they're like degrading and stuff like that.
That is a terrifying job.
I know, right? And so they were basically the use of a laser to do this is not like the way that other scientists are trying to achieve nuclear fusion power plants. They're using something else. I can't remember what it's called, but yeah, hopefully they'll be able to do it and longer than a billionth of a second.
Yeah.
Because that would seriously change the world.
All right. You ready for the next one?
Yeah, number 5.
Number 5. A new microscope can take a 3D image of a cell while it's working in its natural environment.
Whoa.
Which is huge.
3D image of a cell.
Yes. But what this does is it's observing a living cell through a microscope. So it's using a sample. A sample is usually squeezed onto a glass slide. That's usually like how you do it. It then just lies there calmly, and the cells are observed. The disadvantage is that this limits how the cell behaves, and it only produces a 2-dimensional image. 3D microscopes, they already exist.
I did not know that.
This is not new. Yeah, this is not new things, but they work really slowly and they give really poor results in images. The most common type works by recording pixel after pixel in a series, which are then assembled into a 3D image.
Oh, so that must take a long time.
Right. So it's not like watching it move. It's literally just taking a picture and then another picture.
And waiting for the picture to assemble.
Yes. And then it gets like a 3D thing, which is how normal 3D images are taken.
True. I mean, that's how pictures and video is taken as well. It just can happen a little quicker.
Yeah. And this takes time, and often they can't handle more than 1 to 5 shots in a minute.
Oh, okay.
So it's not really practical.
No.
If you're going to photograph something that's moving. So the University Hospital of Northern Norway.
Shout out.
Yeah. is in development of this new technology. So among things, they work to understand and develop better treatment methods for various heart diseases. So they've been studying a living human heart. When you study a human heart, that's really challenging, both for technical reasons and not at least, like, there's also ethical reasons why it's very challenging to study.
You have to get the heart.
Yes.
And clearly it can't.
It's hard to study a heart in a beating body.
Yeah.
In a live body.
Yeah.
Not under anesthesia or anything.
Yeah.
That's very challenging.
Yeah.
So researchers have used stem cells that are manipulated so they can mimic heart cells. And in this way, they can grow organic tissue that behaves as it would in a human heart. And then they can study and test this tissue to understand more about what's happening.
Okay.
So they are really using these 3D images to understand heart disease and study cells within their living actual environment rather than just getting a sample of heart tissue and putting it on a slide.
I mean, that makes sense. That's really cool.
Yeah. I think it's just really fascinating because, it's like jellyfish from our very first episode we ever did where we talked about how jellyfish are under-researched and understudied because you can't take them out of their environment.
Yeah, it's hard to research them outside of their environment because...
You can't.
They die.
You literally can't.
They turn into a plastic bag at that point. Yeah. Now that makes total sense. Like, how do you research living heart cells when they're not in a living heart beating blood? Like, that's not you're gonna get a really weird view of those cells.
And then you can always take an ultrasound of the heart, but that's still not the same as seeing it functioning in real life. So this is allowing them to potentially study heart disease and other potential things down the road as well.
Amazing.
Yeah.
Also, shout out to stem cells again.
Yes. I think stem cells are going to save the world.
Yeah, I think so too. Stem cells and fusion energy.
Yes.
That's the future.
That is.
All right, coming in at number 6. This one was a little it was still big news, but a little less big news. Certainly was not the level of the James Webb. But it was called DART. Did you hear about DART?
I think I did.
Yeah.
But I'm reading this, so
okay.
I remember it after reading it.
So, this was NASA's first test mission for planetary defense. So, DART, which stands for Double Asteroid Redirection Test.
It's a mouthful.
Yeah. Seeks to test and validate a method to protect Earth in case of an asteroid impact threat. The DART mission shifted an asteroid's orbit through kinetic impact, specifically by successfully smashing a spacecraft into the smaller member of the binary asteroid system Didymos. So basically they launched a spacecraft at an asteroid and smashed it into the asteroid to change the orbit of the asteroid.
So we just created more space trash.
Well, yeah, but, So it launched in November of 2021, and it impacted the asteroid on September 26, 2022.
That's kind of sick.
So it took almost a year to get where it needed to go. And then NASA confirmed that the asteroid's orbit had been altered on October 11th, 2022.
That's also honestly kind of cool.
So to make this even cooler, there is video of it. They've videoed it happen. But yeah, if you look up, you literally probably just Google DART video. It happens really fast. It's like all of a sudden the asteroid is there and it crashes into it and the video cuts. That was the first time they had tested that, and they successfully altered asteroid. So if ever in the future there is an asteroid that they think is going to crash into Earth, they can hopefully push it out the way.
But it took them a year to get to it.
Well, that's because they sent it really far away.
To a really far
far away target.
Makes sense.
Number 7.
The reason for T-Rex little arms was discovered this year.
T-Rex arms.
Are discovered.
I think this is the most important
thing that
scientific discovery that's ever been made.
It's honestly hilarious. I'm not gonna lie.
I have to know.
Scientists have spent decades debating the reason and purpose of T-Rex's arms and have never been able to settle on an acceptable answer. Previous hypotheses have suggested that their arms may have been used as pectoral claspers during mating, or to push up off the ground in the event of a fall, which doesn't really make sense.
That doesn't make any sense.
Like, it doesn't make any sense to me, that one.
They are definitely not pushing up off the ground.
No, with those little arms.
Those little things. Come on.
I feel like they'd break underneath them.
Yeah.
But the trouble with each of these is that the activities would have been better served by longer limbs. So there's been no functional explanation explained why they would have evolved to have such tiny, puny little grabbers.
Little grabbers.
But recently, there have been suggestions.
Okay.
We may have been thinking about T-Rex's arms all wrong.
Oh, no.
So a new hypothesis centered on the idea that them getting smaller was precisely the point.
It was all part of the plan.
Yeah.
Really?
The evidence that groups of T-Rex participated in communal feeding, not unlike some modern reptiles, and their arms may have been the target.
Oh, they were eating their arms?
Yeah, because they were all eating together. They were eating each other's arms.
Oh, so this is saying they were eating together and their arms were getting in the way.
Yeah, whether intentionally or unintentionally of another Rex's jaw.
So their arms were just flopping around and it was a feeding frenzy and they were losing arms.
Yes, because they participated in communal feeding.
Right.
So one would stick its arm out and like another one would bite it off.
Another one was already like in chowing.
Yeah.
And takes the arm off.
Yeah. So over time, any benefit their arms presented was outweighed by the risk of getting bitten off by a peer.
Oh my gosh.
So their arms of the T-Rex shriveled because they were an evolutionary advantage to keeping them out of the way.
Huh. Shocked.
I also think that's very interesting that they're saying T-Rexes participate in communal feeding.
That is interesting.
Because tell me one movie where you have seen a pack of T-Rex.
It's a terrifying visual.
There's only ever one.
That's
in the
true.
movie.
They're always the like solitary.
Yeah.
It's like a shark. Like they just travel alone.
They're alone.
They're the apex predator that hunts alone. That's true. Is that like new knowledge as well?
I have no idea.
Because I've never heard that.
No.
A terrifying thought to think about a pack of T-Rexes hunting together.
You wouldn't stand a chance. No wonder it was a feeding frenzy.
That's true.
Eating each other's arms.
Arms were just flying, libs going everywhere. It's crazy.
It's just really aggressive.
Wow.
That's like what's always been very confusing to me about T-Rex, honestly. Like, they're an apex predator, but you look at your arms and you're like, man, what are you doing with those?
Come on, man. Those are just silly. Okay, number 8. Some more stem cell.
Let's go.
Coming in. Lab-grown brain cells play Pong. So this one, at least reading about it though, it did seem like there was like a ton of controversy of like, like the scientists, the specific doctor was like really putting out some big claims that his peers were like, I don't know about that. Maybe just take it with a grain of salt. So Dr. Brett Kagan of the company Cortical Labs claims to have created the first sentient lab-grown brain in a dish. He says it is able to take in information from an external source, process it, and then respond to it in real time.
No way.
Mini brains, which I guess are what they're called,
Sure.
were first produced in 2013 to study microcephaly,
Sure.
a genetic disorder where the brain is too small. I haven't heard of that.
I haven't either.
Yeah.
It's a new one to me.
And they've since been used for research into just general brain development. But this is the first time that they have been plugged into and interacted with an external environment, in this case, a video game.
I just don't understand how.
So the research team grew 800,000 human brain cells from stem cells and some from mouse embryos.
This feels really screwed up. I'm sorry.
And
I understand it's for science, but this feels really not okay.
And then they connected that mini brain to a video game via electrodes. So basically the electrodes told the brain, it sent signals, electrical signals, based on where the ball in Pong was. If it was like on the right of the paddle or the left of the paddle. So the brain would get a different signal. Then the brain would fire back a signal that would place the paddle somewhere. That was how the signals were being sent and received.
This hurts my brain.
So the mini brain learned to play in 5 minutes.
What?
It often missed the ball, but its success rate was well above just pure random chance. So they're saying like something had to be going on.
Sure.
Although it has zero consciousness, it does not know that it's playing Pong in the way that a human player would know that it's playing Pong.
Mm-hmm.
The researchers stressed that there's no consciousness going on there.
Sure.
So yeah, I mean, then it, basically it said like other experts in the field described this work as very exciting, but like I said, they are skeptical and they think calling the brain sentient is a bit too far.
I agree with that.
Yeah. I mean, I think it's exciting research, just that those things are being looked at.
Yeah.
But it does seem like they're making some big claims, and like the way they achieved it seemed very like not rigged to make it happen, but just like ultra best case, like setting it up exactly how it needed to be.
Yeah.
I don't know. So
that's interesting.
Yeah.
I don't know how I feel about it. That's really cool. It's awesome research and I'm glad someone is doing it, but it's very like, I don't know.
I think for the future of like brain development knowledge, it's great research.
Yeah.
Right? But, maybe just call it that. Don't try to make it seem like a little brain you grew is playing a video game. But who knows?
Whatever,
maybe it'll get the high score.
That'd be kind of sick.
Become like
Become a pro.
The Pong master.
Does it have to sleep?
No, you just play nonstop, I bet.
I bet.
Crush that high score.
Crazy.
Yeah.
All right, number 9.
Number 9.
We're kind of shifting. The world's largest active volcano woke up again after almost 40 years of silence.
Yeah.
This was it was the longest it's been silenced.
Yeah.
So Hawaii's Mauna Loa volcano is erupting.
Big time.
I think it's still erupting.
I think it's still going on.
It's still going.
This just happened not too long ago.
No.
It was like a month ago or so.
Yeah.
Yeah.
The sleeping giant has been so quiet in the past that it's honestly scary that it's erupting.
Yeah, I hadn't heard from it for a long time.
Yeah, it's been napping.
It was taking a big nap.
It's honestly what it says right here. So it says historically, the Mauna Loa would awaken every 7 years or so on average.
Oh.
Yeah. The last stretch between eruptions is quite a big gap.
Sure.
Or quite a big nap.
The big nap.
Yeah, it took a big nap.
Yeah.
But my big question was, were there warning signs that Mauna Loa was about to erupt?
Right. Did anyone know?
Yes, because usually geologists have a very strong pulse on this.
Yeah, it's pretty obvious that the ground is about
will start
to
shaking.
Explode.
Yeah.
Yeah.
So the scientist that was on this said, it depends on what you mean by warning.
Ingrid Johansson is
Johansson.
The scientist talking about this.
She said, it depends on what you mean by warning. In a manner of speaking, We've known that the Mauna Loa was showing signs of unrest since 2015.
It was stirring.
It's been stirring. Yeah. At the time, she says there was an uptick in rate of local earthquakes, as well as in the GPS observation of land deformation. So basically there was a bulging upward of the land surface that indicates magma is on the move below the ground.
Dude, that's terrifying.
Can you imagine watching like a volcano and being like, oh, it's bulging? Like it's literally bulging.
Well, like, could you imagine just living there and being like, that hill is taller than it was?
Yeah.
You know, like a couple months ago,
it was not that big.
That tall.
Or like round.
Or yeah, it's like really just growing. What's happening there?
It's terrifying. But those signs actually tapered off a bit and then increased again over the last 6 months.
Okay.
Which suggested to them that the situation was evolving.
Okay.
And not good that
not
it was
good.
evolving.
Something was happening.
Yeah, something was getting ready to happen. But when the volcano would actually erupt is basically impossible to determine. It's impossible to determine when any volcano is going to explode.
Right.
It's kind of like when you squeeze a baggie.
It's true. Yeah, you don't know the exact moment of which it's going to
explode,
pop.
But you can watch it begin to swell.
Yeah, that's a good, yeah.
But you don't know exactly when it's going to blow.
Right.
So it's pretty much impossible for them to determine when it's going to blow. But fundamentally, they had about an hour and a half of warning.
Oh, wow.
That was the time frame between when researchers noticed a sudden swarm of earthquakes, pointing to an imminent eruption and the emergence of lava.
I feel like the emergence of lava is a pretty clear.
Yeah.
Once you start seeing,
I just think it's crazy that they were looking at and they were like, "This thing's literally about to go." We have an hour and like. There was an hour and a half.
That's crazy.
From when it was freaking out, the ground was freaking out, to it literally exploded. They also said that the short notice is in true form of the Mauna Loa. Other eruptions have evolved very quickly in the same matter of it.
Oh, okay. So they were used to it.
Yeah, they were like, she gives us a very short notice, but it's very concerning that it's been silent for 40 years. I think that is crazy.
That is very weird. I mean, just the like suspense that's built up that time of like, it's going to happen at some point.
At some point.
It has to. I feel like that's kind of like Yellowstone. People keep talking about like, it's just, waiting for that. I feel like we should do an episode on
absolutely
at least volcanoes.
Yeah.
Because they're fascinating.
I think it's really, what's also really interesting to think about is 40 years. That means someone studying this volcano spent their whole career probably waiting. Multiple people just waiting for this thing to erupt, and it just like never did. 40 years is a long time. That's a lot of life.
That's a lot of life. That's like you got your degree in volcanology.
Yeah.
And moved around to different volcanoes and found your way there and retired and never saw it erupt. Like, even though everyone's like, yeah, every 7 years. You see it a ton. And it never did.
So scientists reported yesterday that the world's largest active volcano is no longer producing lava.
Oh, nice.
That is moving outside and down the mountain.
Okay.
But the rift zone may still be active.
Okay, so don't go there.
Don't go there.
Yeah. I might have gone to this volcano.
It's a very common one to go to.
Because I, many years ago, went on a trip with my family to Hawaii. We went to the Big Island and went to like Volcano National Park or whatever.
Yeah.
And I would assume this is that.
Yeah.
Yeah, and it wasn't really doing anything at that time.
Yeah, so as of December 12th, it is no longer exploding.
It's no longer a massive threat.
Very interesting.
If we have any listeners from Hawaii,
let us know.
What's up. Yeah. How's it going? There is a breakfast diner. I don't know what it's called. On the Big Island of Hawaii. Just outside of, what is that airport called? This tiny airport that we flew into that was like an outdoor airport. Best breakfast ever, though.
Really?
So good.
I'll have to check it out
Fresh.
if I ever go.
Really great.
Noted.
Okay, the last one.
Round us out.
Coming in with some space.
Of course.
The big space.
Big space.
I mean, James Webb was huge.
It was a big year for space.
It was a big year for space.
Yeah, and hopefully it's going to get even bigger the next couple years.
If everything goes to plan,
the
next couple of years, it's just going to get even bigger. So, yeah, couldn't round out the year without talking about Artemis.
Space.
NASA's Artemis program. That is their new space program. Like we talked about Apollo earlier. This is the next iteration. Artemis 1 was the first integrated launch of NASA's Deep Space Exploration Systems, which is the Orion spacecraft, Space Launch System rocket, and the ground systems at the agency in Kennedy Space Center in Florida. So it's all of that is like a whole new system they've built, set up to do these new missions.
It's crazy.
It is the first in a series of increasingly complex missions. Artemis 1 will demonstrate the performance of both Orion and the SLS rocket and test the capabilities to orbit the moon and return to Earth. Now, I wrote this a week ago. So this is they're back.
Yeah, they're back.
I wrote this before they had come back. So everything is like, it will do it. Well, it's done it.
It did it.
Yeah. This flight will pave the way for future missions to the lunar vicinity, including landing the first woman and first person of color on the surface of the moon.
Woo!
Which is huge, yeah.
That is massive.
The Orion spacecraft launch on November 16th, and it will splash back down on Earth on December 11th. So
it did that.
It did that. Yay. It was a success. This was a cool fact. Every state in the United States has contributed to building Artemis.
Really?
So they had a map on, this is everything, all this just came straight from NASA.
Cool.
They had a map that literally, there is some form of factory part, something.
That is so cool.
From every single state in the United States.
What did Alaska contribute?
I have no idea. I didn't read through every state. I did go and look at
the oil.
I looked at Utah, and it was something to do with the thrusters, rocket thrusters.
Well, they tested it here.
Yeah, they tested the thruster here first before,
which was so cool,
shipping it to Florida. Yeah, I mean, basically everything. They're hard at work they want to establish a long-term human presence at the moon. That's the goal. Work is already big time underway for Artemis 2, which will hopefully launch. I had originally 2023. I think the new date is in 2024.
Makes sense.
There's not an actual date yet, but and that will take astronauts into lunar orbit. It'll basically be the same mission.
Yeah.
But this time there will be people aboard.
That's so cool.
And then Artemis 3, which again, no date because that will depend on Artemis 2.
Yeah.
I think will actually land people on the moon.
That's amazing.
You know, we did a whole episode about the history of spaceflight. I'm a huge space nerd. The amount of movies and just stuff I've read about the space race, those people got to see that happen. And now to actually see that happen again.
We're watching it happen.
We're watching it happen again in our lifetime.
Which I think is something that none of us really expected.
I mean, the space program was pretty quiet for a long time.
Yeah.
And did not have the same funding that it used to. And so now, seeing it churn up again and get that going again.
It's exciting.
It's so exciting. And it's, it's one of those things that like, if everything goes to plan, we could see Mars not too long,
Yeah.
30s, maybe 2030s.
Yeah. Monday we'll be talking about that in the year wrapped up.
The year wrapped up, man. in like 20 years.
We'll be like 50 doing this podcast.
So old. We'll be rolling out in our wheelchairs.
Yeah,
like,
literally.
Let me tell you, kids.
Well, let's tell you what happened back in our day. That'd be crazy.
Yeah.
But that's the year.
That's the year.
Those are the things that Josh and I found interesting, that some were hot news, some weren't hot news, and
all pretty hot. I mean, for the most part, it's all, like I said, like all something that's like, this is building to a better future.
Yeah. Guys, if you like the podcast, leave us a rating and review.
Helps us out.
It does.
So much.
Also, send us your podcast ideas to the email.
Yeah, because after this, we're just going to keep it going. Podcast ideas.
Yeah.
Fan listeners submitted. We've already laid out a couple for the next year. As long as you keep sending them, we're going to keep doing them.
Maybe eventually we'll have to go back to Josh and I's ideas.
We might. That's going to be a dark time.
Please don't let us do
that.
The
quality in ideas is really going to tank.
It's going to really tank. It's going to be really bad. Really bad. Well, I feel like we should start planning for next year.
I think so. We should go write out the next couple and see where the next year takes us.
All right, guys. Well, we'll see you in the new year.
Yeah. Hope you had a great holiday season.
Yeah.
And just a great 2022. And we'll see you in 2023.
You!
Yay!
Bye, Science Pals.
Bye, everyone.